Talk about completing the square today. In this video, we have four kind of levels of problems. We have an easy one, kind of one that uses imaginary numbers when we get the answer. One that has a square root and imaginary numbers for number 3, and the last one has fractions. So if you have one of these types, or maybe one that's similar to your homework, maybe go to that part of the video, and hopefully this will help you out. But we're going to start here with this first one, just so we get an idea of how to complete the square, and then we'll work our way up from there. All right, the first one's going to be our easy one, and the first thing I'm seeing with all of these is that they're all divisible by 3. So if you can take out a GCF for a greatest common factor, that is what we want to do first. And this one doesn't have an x, so I can't take out any variables, just the 3 here. This is going to leave me with x squared minus 42 divided by 3 is 14, 14x, and then of course this one is 15. This one's also nice because our constant term, just the number, is already on the right side of our equal sign, and so that is good. Some people also like to leave a little space here. If you want to do that, you can. And I might grab another marker just to help us out, because the next step when it comes to completing the square, if you've done this before, if you haven't, that's fine too, is we're going to take half of our b term, which in this case is 14, so half of that is 7, and I'm going to square that. If you want to do that off to the side, you can. Think 14 divided by 2, and square that. Well, that's 7 squared, which is 49. So I'm going to add in 49 right there. Now, if you've done math for any length of time, you know that you can't just add something to an equation unless you do it to both sides. Then it's still equal. Right now, this equal sign is not true because there's not a pink part over there. I have to also add 49 to both sides. All right, what happens when I do that? Well, the right side, of course, is going to be 64, which is going to turn out nice here in a little bit. The left side, let me just rewrite this, is going to be x squared minus 14x, that's a terrible 14x plus 49. The left side we need to write as what's called a binomial squared, all right? And to do that, binomial means 2 terms. Currently we have 3, and I can do this. The reason I chose those numbers as 49 is because it turns out that I can make a perfect square out of it, which, if I were to FOIL, would turn into this, okay? And the way we do it is if I take the square root of my first and my last term, I'm going to get x and 7. You might remember that 7 from earlier, which is when we did 14 divided by 2. The other part is I'm always going to use the sign in front of my b term. So I'm kind of taking one thing from each. I take the square root of the a, the square root of the c, that's x and 7, and then from the b, I'm going to take the sign. So this is going to get a negative right there. Some teachers teach you to take half of this negative 14. That's going to give you negative 7. That's what you put in. That's fine. I like to think of it as taking one thing from each, but we get the same result. All right, now this is a binomial squared. If I were to FOIL this back together, x minus 7 times x minus 7, that's going to give me this term, or this the trinomial, and it still equals my right side, which is 64. Why did I do that? Because now, if this is all squared, I can undo it with taking the square root. And you'll notice that 64 turns out real nice when I do that. So that's going to cancel the square and square root on the left side, leave me with that binomial of just x minus 7. On the right side, the square root of 64 is, no, it's plus or minus 8, right? Got you on that one, all right? So we got to put the plus or minus in there, and then we can put the 8. There's actually 2 solutions to that problem, and most of your answers here with completed square will also have 2 solutions. I'm going to add 7 to both sides. And typically what you want to do is take this 8 and do kind of plus 8, plus 7, and minus 8, plus 7. You can think of them as kind of 2 different problems here. 8 plus 7, of course, is 15. Negative 8 plus 7 is negative 1. So my 2 answers for this problem are going to be positive 15 and negative 1. All right, this next one's going to be a little bit trickier. And it doesn't look like much. It says 6r squared plus 6r equals negative 12. Again, this has a GCF of 6, so we can divide each of those terms by 6 and get r squared plus r equals negative 2. All right. Again, we're going to take half of our b term, which in this case is 1, and half of 1 is 1/2. And if I square that, now I'm going to have 1/4. All right, so again, I'll use my other marker here, and I'm going to say I still have r squared plus r. I'm going to add in 1/4 and equals the other side negative 2. I also have to add in 1/4 to the other side. If I do it to one side, I gotta do it to the other side. The reason why we chose this is because this left side is gonna become a binomial squared. Again, that reason, if I take the square root of r squared, that's r, square root of 1/4, we'll kind of go backwards here, is 1/2. And the sign I'm using is the plus from in front of my b term. The other side, if I think of this, well, 2, that is, or negative 2 is negative 8/4, right? So this would be negative 8/4 plus 1/4. Well, it's negative 7/4. And yes, it is going to be easier to leave that as a fraction. I know you don't like that. You probably want to change that to be negative 1.75 in your calculator, but don't. All right, anyway, let's go ahead and take the square root of both sides so we can undo this square. Square and square root cancel. Leave me with r plus 1/2 on the left side. On the right side, I'm going to leave the top as, well, I guess I can take out an I because it's negative here. So it's going to have I square roots of 7. I'm going to leave that square root over the 7. However, on the bottom, what is the square root of 4? Well, it's 2. And because I took the square root, I need a plus or minus in front of that. All right, last step here to solve for r is I'm going to subtract 1/2. And so my final answer, normally we can leave this plus or minus kind of in the middle of that. So if I move this negative 1/2 over, I'm going to have r equals negative 1/2 plus or minus I root 7 all over 2. Some teachers like you to combine these halves since they're both over 2. And if yours does, then I could keep my answer as negative 1 plus or minus I root 7 and have it all over 2. Those two things, I'll circle them or square them, those are equivalent. So a little bit ugly with the I, but kind of that's the next level. Let's try a harder one. All right, number 3, one thing that's tricky right off the bat is that this 100 is on the left side. We need it on the right side. However, before we do that even, these are all divisible by 4. So let's divide by 4 and get m squared minus, and then 8 divided by 4 is 2m, and of course that is 25 equals 0. Let's move that 25 to the other side, and I will just do this. I'm going to subtract 25 from both, like that. I'm going to leave my space right there for half of the b term squared. Speaking of, half of negative 2 is going to be negative 1. So let's go 2 divided by 2 squared. Well, that's 1 squared, which is 1. So really, we're adding in 1 right here to both sides. The reason I chose that one, again, is because I can write this as a binomial squared. Square root of m squared is m. Square root of 1 squared is 1. I'm using the sign from my b term as a negative. On the right side, negative 25 plus 1 is negative 24. Just like that. All right, so this could be a little interesting we'll probably have to get an interesting square root in there. Let's take the square root of both sides. So this is going to cancel, leave me with just m minus 1. And that right side, let's see, how can 24 be split into something nice? Is 4 the biggest, 4 and 6? Yeah, because 6 would be 2 and 3. Anyway, what I'm doing there is I'm saying that the square root of 24 is the same as the square root of 4 times the square root of 6, which would be 2 square roots of 6. I also have to take out a plus or minus with this and an I, so I'm going to say plus or minus 2i for the negative root 6. All right, so far this is all equal. The last part here is to get the m by itself, I'm going to add 1. And then we get m equals 1 plus or minus 2i root 6. Okay, I don't know. That one might have been equally as hard as the last one. There wasn't any fractions or anything to deal with, but this next one, it's a doozy. Let's try it. All right, this last one could be a little bit tricky for a few reasons here. First off, I am seeing that my 1/8 has to be moved to the right side. There is no GCF in this one, so I can just say x squared minus 3/4 x equals, I might leave a space there, equals negative 1/8, all right? Now I'm going to take my other marker because in that space that we made, we need to find half of our b term and square it. So currently I have 3/4, and you know what? I'm going to take half of it. So of, remember, means multiply. So I can do it like this and then square that. On the inside here, that's going to be 3/8 if I multiply across the top and bottom, and then squared is going to be 9/64. So I'm going to add in 9/64 to both sides. All right, since I'm going to do it to both sides, that's okay. And also, the reason I chose that number is because I can write the left side as a binomial squared. The square root of my a and c is going to be x, and then remember the square root of this, if I think just backwards a step, is 3/8. 3/8. The sign I'm using, it comes from in front of my b term there, if I think a, b, and c. All right, and then the other side, well, I need common denominators if I want to put those together. 64 is going to be that. 8 times 8 would be 64. So if I multiply the top times 8, this would be the same thing as saying -8/64 plus 9/64, which turns out to be 1/64. So this right side has just 1/64, which will turn out a little bit nicer than something else it could have been, right? All right, take the square root of both sides here. The square and square root will cancel on the left side, giving me just x minus 3/8. On the right side, I can take the square root of both the top and the bottom. Square root of 1 is 1. Square root of 64 is 8. All right, however, I do need a plus or minus in front there. And really, this isn't going to turn out to be too bad, but we do have some fractions here. So I'm going to add 3/8 to both sides. Plus 3/8 plus 3/8. And I get x equals, let's think about this here. Let's do it into two steps. 3/8 plus 1/8 and 3/8 minus 1/8. Well, 3 plus 1 is 4/8. These are all equal, by the way, which is 1/2. And on the other side, 3 minus 1 is 2/8, which, of course, is 1/4. So the answers for this ugly looking problem here turn out to be 1/2 and 1/4. Hopefully this helped you out. Until next time, keep doing your math homework fast and accurately.